In this video, we want to take a better look on the process of creating a line. And this is using that last form of the line known as point-slope form. Now, we'll also need to know a little bit of additional information on when lines are parallel, perpendicular, or when you just have two ordinary lines and they're not parallel or perpendicular. Recall from earlier that there are basically three forms that you can write a line. And we've already looked at slope-intercept form and standard form, which were really good for graphing. And the last form that we didn't cover was point-slope form. Well, point-slope form is really good when you want to start building the equation of a line. And the way it works is that if you know the point and you know a slope, then you can actually go ahead and build the line. So point-slope form looks like this. It says y minus y1 equals m times the quantity x minus x1. And the way you want to read it is that the point is the x1 and the y1, so basically the coordinates of that point. And m is considered the slope. Now you may notice there's also a couple of other x's and y's in there, and they do not have subscripts. With those x and y, they actually stay in the equation, and we don't actually touch them whatsoever. What you'll see is that we end up substituting values for the x1 and y1 and for the slope, and that the other x and y just stay where they are. To see the formula for point, slope, and action, I have a couple of examples that we'll give it a try on. So in the first one, I basically want to build the equation of a line that has a slope of 1/2 and it goes through the point -2, 4. Well, those two bits of information are exactly what I need in the formula. So let's go ahead and bring that formula up. So what I'm going to do is I'm going to substitute the 1/2 in for m, and then I'm going to take the -2 and the 4 and put them in for x1 and y1. Let's see what that looks like. All right. So by substituting things in there, I have basically formed the equation of a line. Now, usually we take this a little bit further and we actually write it in one of those other forms. And that's what I'm going to do right now. I'm going to take this and now I'm going to write it into slope-intercept form. So that means I'm going to try and get y on one side and then have my slope clearly in front of x. Okay, so in order to do this, first I'll take care of that -2 inside parentheses. And of course that becomes a +2. Then I'll take care of the 1/2 in front of parentheses by distributing it inside. So 1/2 times x and 1/2 times 2. All right, lastly, to get y completely all alone, I'll add 4 to both sides. And there you have it. So the line is y equals 1/2 x plus 5. And I can be guaranteed that it has a slope of 1/2 and that it definitely goes through the point -2, 4. All right, so not too bad. Let's see point-slope form again with another example. This time, it's a little bit different. I want to create the equation of a line that just goes through these two particular points, 5, -1, and 0, 3. Now notice how with this one, we don't have any information about the slope. So if I'm going to use point-slope form, that's the first thing I need. I need to find the slope between these 2 points. Well, fortunately, we saw earlier how to go about doing this. You subtract the y values and you subtract the x values in order to find that slope. Well, I'm going to save the trouble of those steps and tell you that I've already done it ahead of time and that the slope between these 2 points is 4 over a -5. All right, so that's the slope we need. Now we come across a second minor issue. In order to use point-slope form, we need a point. But actually, if you look at this, we have 2 points. So which one do we end up using? Well, the good news is it really doesn't matter which one you use. You could decide to use the 5, -1, or you could decide to use the 0, 3. Either point will give you the same equation in the end. So I'm going to use the 0, 3 and my slope, and I'm going to plug those both into point-slope form. As you can see, I've substituted for x1, y1, and the m. Now, like before, I'll usually take this and write it in another form. So I'm going to take this and write it into slope-intercept form. Okay, let me take care of that 0, since x minus 0 is just x. And then I'm going to add 3 to both sides. There you go. So in slope-intercept form, the equation of this line is y equals a -4/5 x plus 3. As you can see, when using point-slope form in order to build a line, it's essential that you need the slope and that you need a single point. Well, in a few problems, you'll see that you're not always given the slope directly. And in order to figure these out, you need to know a little bit about parallel lines and perpendicular lines. Okay? So here's what they are. If you have two lines that are parallel, it means that they have exactly the same slope. So as you can see in my top diagram, I have two lines, the blue line and the red line, and they have exactly the same steepness or the same slope. Now, if two lines are perpendicular, that means their slopes are negative reciprocals of one another. Now, that's a little bit more difficult to describe. If you look at the picture, it basically means that they cross at a right angle. All right? Now, if you're looking at the perpendicular requirement and going, all right, how do I really know if one slope is a negative reciprocal of another? Don't worry, I got you covered. There's actually a quick test that you can apply to see if two lines are perpendicular or not. So here's the perpendicular test. What you do is you take the slopes of both the lines and you multiply them together. If when you multiply them together you get a -1, that's the sign that the two lines are definitely perpendicular. Now if you take those two slopes and you multiply them together and you get any number other than -1, so anything else, that means they are not perpendicular. So they could just be two ordinary lines. So using this test, you can definitely know if two lines are perpendicular. Let's take a look at an example where this information is going to be useful. I want to write the equation of a line that is parallel to this given line, and it happens to go through the point 2, -3. So as you can see immediately, I do have a point that I can use, but I'm not really sure what the slope is. So in order to proceed through this example, I first need to figure out what the slope is of this line, the 4y equals x plus 20, and then I need to put all of that information into point slope form. All right? So let's go ahead and give this a try. I'm going to start with the 4y equals x plus 20 and write it in slope-intercept form. In this way, I'll be able to read what its slope is. So in order to put this into slope-intercept form, I need to get y all alone. So I'm just going to divide everything by 4. This will give me y equals 1/4 x plus 5. Now when it's written in this form, I can see that its slope is 1/4. Now that's excellent information, because the slope of the line that I'm trying to build happens to be parallel, which means it's going to have the same slope. So I'm going to use that 1/4 as my slope, and I'm going to use the given point. And with those two bits of information, I'm going to try and build my line using point slope form. All right, so I'm going to substitute in the 1/4 for m and substitute in the 2, -3 for the x1 and the y1. All right, let's see how that works. So I just substitute all of that information in there, and then of course try and simplify this, or maybe even write it into another form, like slope-intercept form. Well, to write this one into slope-intercept form, I want to take care of that 1/4 in front of parentheses by distributing it in, and remember that 1/4 times 2 will give you 2/4, which reduces to 1/2. Also, I have a -3, which will change into a +3. All right, we almost have this thing done. My last thing that I need to do is subtract 3 from both sides. So I subtracted 3 from the left and from the right, and this will give me y equals 1/4 x minus a 7/2. So that is the equation of the line that happens to be parallel to our given line, and it goes through the point 2, -3.